welcome everybody. We have a special session tonight of IoT Central. It's a developer session with Kaa open source IoT platform. We're lucky to have them here tonight. And how many people, this is your first IoT meetup? By show of hands? Okay, quite a few. Cool. And how did you hear about us? I'm just curious, just a few people, how did you hear about IoT Central? Okay, cool. Looking on Meetup. Anyone else? Meetup search. Okay, great. Well, we're glad you found us, and we're really happy to have you here. We've been running for it's almost been a year since our first event, and we're now at about 2,300 members. So we're really lucky to have you guys as part of our community. And let me just. So first of all, I'd like to thank our sponsor. This is an ongoing sponsor of the IoT Central Meetup, which is Atmel. And we heard a bit from Dan Uchvari at the last session and one before. But Atmel is a great company offering hardware solutions for the Internet of Things. And we'll have more on them in the future. And a big thank you to our host and sponsor for the drinks back here, which is General Assembly. So we're sitting here in the General Assembly space in New York, and they've hosted several of our meetups, and we're really thankful to them. So the agenda is going to be pretty focused tonight. Really, this session is really geared towards developers. So the idea really is to give more information about open source, the open source Kaa platform. So in the beginning, we had some networking, and now we're doing the welcome and intro. We'll go right into Kaa intro and some demos. They have some really cool stuff to show us, including some things that interact with Twitter. So get ready to tweet. And we'll have a Q&A after that, followed by member announcements. And member announcements are a chance that if you're to take 20 seconds or 30 seconds to say what you're looking for, if you're looking for a job, if you're looking for, if you're a consultant and you want to do some consulting work, if you have expertise in a certain area or you're looking for expertise in a specific area, like that's your time to shout it out to the group, and it's a good way to find somebody who can connect you with that type of opportunity. Then we'll do a little bit of more networking and the end of the program. What is IoT Central? So IoT Central our mission is really to inspire, engage, and connect entrepreneurs, investors, professionals, and enthusiasts worldwide who are active in the Internet of Things. So we do that through these monthly sessions where we talk about either an industry vertical, such as healthcare. For example, we did an event around healthcare, or we talk about horizontals such as cybersecurity and IoT, or this session, which is on the Kaa open source platform for IoT. So we either hit a vertical or a horizontal. We've also done some larger events like the IoT Fair back in December. Was anybody at the IoT Fair in December? Okay, our videographer Jolly was there. So we had a big IoT fair with about 500 people in attendance and about 23 companies presenting. So we hope to do more events like that in the future as well with your support. So the IoT Meetup is made up of people from a vast number of fields, software developers, electrical engineers, user interface people, user experience people, graphic designers, mobile developers, industrial designers, business people, investors. So there's a whole ton of different fields that people come from. But also, if you look at the companies, the participants are coming from a very wide range of companies, all the way from small startups where it's 2 people, with an idea in a garage, or the equivalent in New York City, and all the way up to larger corporates, and including everything in between, such as service providers and SMBs. Angel investors and VCs are also in the mix. So it's quite a diverse group of people in the membership here. So we're really a community, and the whole idea here is that as we're a smaller community here in New York of IoT professionals than in Silicon Valley, let's say, or some other areas, we really are encouraging community so that people can help each other to find the right opportunities and find solutions to their IoT issues. We've had many companies present at IoT Central, at these meetups and also at the IoT Fair. So we've had well over 50 companies present so far. These are just a sampling of those. But you can see in the last one we had companies like ARM present, and we've had Atmel, and we've had large companies, as well as relatively small companies up here that you can see on the list. So there are many ways to be in touch with IoT Central, and here are some of them. On Twitter, the hashtag IoT Central, or our Twitter account is @IoT Central, no, just one word. You can go to meetup.com/nyc-iot. So if you haven't registered through the Meetup site and you came to the event, make sure that you register on meetup.com/nyc-iot so that you can get more information about the events. You can come to YouTube for our YouTube channel, youtube.com/nyc-iot. That has lots of good content, videos from previous sessions. So if you're interested in any of those, go there. And if you are interested in more specific information, you can always contact me, Mitchell at iotcentral.co. This is our email list. It's a powerful tool. This has about 2,000 members on it. So if you want to post a question or pose a question to the group, you can write that here. And if you have a question on something, or you're showing some new opportunity with an IoT or related to IoT, you're welcome to use that list. So it's a very powerful tool. It's nyc-iot-list at meetup.com. And you can find that on the Meetup site as well. So that brings us to the main part of our program. And so we're lucky to have tonight with us Andrew, and I'm going to try to pronounce your last name. It's Kokhanovskyi. Okay, Andrew Kokhanovskyi, who is from CyberVision. He has 20+ years of experience well, CyberVision is a 20+ years software services company. We're about to say that he was programming since 3. No, but maybe a little later. Anyway, so CyberVision is 20+ year software services company with a strong expertise in IoT, consumer electronics, big data and analytics, mobility, and telecom. Andrew is the Chief Technology Officer at CyberVision. Andrew oversees CyberVision's engineering teams and also leads the R&D group that works on Kaa open source IoT platform. Prior to his role as CTO, Andrew held technical and project management positions where he was responsible for the architecture, technology, and delivery of various projects in mobility, embedded data management, telecommunications, and other areas. It's my great pleasure to welcome Andrew.
Thank you. So, by 2020, 50 billion devices will be connected to the Internet of Things. Wait, don't go just yet. We all heard this. Let's think about this number for just a second. Mitch actually did a very good job introducing me, so I'll skip that part. As a company, we've been working with many industry leaders, especially in IoT space, in consumer electronics, in mobility, big data, and others. What we have found was that many of the companies spend between 300 and 500 staff days of their engineers on just getting the first product deployment of their backend system to the market. These are, of course, average numbers. They may differ from yours, but this is what we have seen. So 50 billion devices. Let's assume that most of these devices will be brought in by, well, fairly successful companies, each company delivering about 100,000 connected devices to the market, right? So where this gets us is, if you divide by the amount of companies out there, that leads us to 200,000 staff days spent globally in the next 4 years just to build this backend infrastructure for the Internet of Things for every company separately. With the average life expectancy of 80 years, that's 10,000 people's lives. We have better ways to spend our lives. So what I want to do right now is introduce to you the platform that saves lives. Maybe not 10,000, but we'll get pretty many of those. So what is Kaa, first of all? How many of you have heard about it previously? 1, 2, you don't count, 3, 4. All right, that's pretty good. So Kaa is a middleware application platform that allows you to rapidly build IoT applications. It basically gives you a fairly ready-to-use backend for your applications, products, solutions. I will talk a little bit about what the platform does in a moment. The first thing to remember about Kaa is that Kaa is not a message bus. There are so many platforms out there that are IoT platforms, and essentially their primary function is to be a message bus. So Kaa is much more than just that. What the platform does out of the box is, first of all, it's identity management. We also call it profiling. So this is the capability to get a list of devices that are deployed to the field after they are unboxed in your backend database. Not only the records that there is an object that exists out there, but also an associated profile. So this profile can be pretty much anything. Any kind of data that you want to know about your endpoints, about your applications, about your gadgets, whether it be firmware version, hardware version, date of manufacturing, any extensions that are installed, anything else. The reason why the platform is very much flexible and horizontal is because it uses Apache Avro as the engine for defining schemas of the data. So the platform essentially knows the semantics of the data that it operates against. It's not a generic platform that just sends bytes over the network, but it's actually a platform that knows what these bytes are about. So that leads us to a capability at the platform layer, already implemented in the platform, to filter these endpoints by any properties that are available in the profile and construct groups that can be managed separately. So your devices can be separated into groups depending on their location, on their firmware version, on who their user is, when they were purchased, and so on and so forth, and the battery, on the average battery capacity, or for how long it lasts. So that gets us to the second area of functionality. That's device management. It comes in two forms. There are notifications, and there is data distribution, which we also call configuration. So let's start with notifications. Those are simple. I think that everyone understands what notifications are. That's basically your regular suspects. You have topics that the endpoints can subscribe to. You can inject messages from the server, and they get delivered to the endpoints. You can use this to deliver messages to engage users. You can use those to deliver software updates, and many more. Now, configuration is slightly different. Configuration is, unlike notifications, which are one time, they come and go. Configuration is something that is persisted in the endpoint. So by using configuration, you can alter the way in which endpoints operate. So if you want, for example, if you're doing like sensory, like if you're doing like sensors data collection, right, and you want your sensors installed in the city to report back to your database more frequently than the sensors outside of the city, then you can create a group for those who sit in the city and reconfigure them so that they would send data more frequently. The next thing is messaging. So this is also very much familiar. So that's the capability to send short or long. Actually, Kaa as a platform is not does not limit the size of the package otherwise than by the device memory. So you can send messages from one endpoint to the other endpoint, even across the applications. So that's the thing that allows you to do, for example, control of your home equipment from a mobile phone and so on. And last but not the least, it's data collection. We also call it logging. Some people call it telemetry. So that's the capability to extract data from the endpoint devices and bring them all the way into your cloud and inject into your data processing or data storage system. Kaa is pre-integrated with pretty much everything that you would care to mention in the NoSQL. Yeah, go ahead. Sorry, say it again. Mitch, what's the procedure here? I'm fine. Yeah, go ahead.
Does Kaa provide or actually limit any the kind of data that it provides, or can it be anything? In other words, can it be just numbers or letters, or can it be like as complex as spatial objects?
It can be as complex as Apache Avro permits. So Apache Avro is used as the data structure definition language, and it's actually very much flexible. And you'll see that in like 5 minutes or so when I'll be showing this. Yeah, you can define as complex data structures as you prefer. It's not limited just to words or binaries packets. So the platform is pre-integrated with many NoSQL, SQL, and big data sort of data processing system, including Cassandra, MongoDB, Hadoop, Oracle, NoSQL, Storm, Spark, and many, many others. So there are industry standard interfaces, and there are specific interfaces for the specific database and data processing solutions. Now, a couple of words about the architecture of the platform. So this is a very modern architecture, to some extent similar to that of Hadoop. The cluster is controlled by a Zookeeper. So this is a fault-redundant and scalable architecture. There are 3 primary types of services in the server. There are Bootstrap, operation, and control servers. Bootstrap servers essentially act as the naming service for the endpoints. When they boot up for the first time, what they do first is they go to the Bootstrap. The list is baked into the SDK itself. They go to the Bootstrap server and they resolve the currently active list of the active operation servers. So you can add more operation servers on the go, and their list will be automatically updated in the endpoints through Bootstrap. Now, operation servers are the ones who, oh, somebody's tweeting, that's cool. So operation servers are the hard workers. They do most of the heavy lifting for the platform, and they are pretty much stateless. So you can add more operation servers, like I said, on the go. And if any of those fails, nobody really cares. Zookeeper gets the updated information that gets the update that the operation server failed, distributes that to Bootstrap, and the endpoints just reconnect to the next operation server in their existing list. So that makes it, yeah, go ahead.
Quick question. Can you hear me? The endpoints, the assumption is IP based, or you support other kind of protocols?
That's a very good question, and I'm glad that you asked. The way we architected the platform is for it to be transport agnostic. So we have several existing transports that are available from the open source distribution, and those are based on, one is TCP based. It's very similar to MQTT, very small header, very lean. The other one is HTTP, HTTPS, and basically REST, similar to REST. But you're free to essentially implement any transport protocol that you prefer. It can be IP based, it can be not IP based. All we care about is that the data packets get delivered somehow from the endpoints to the server, and of course vice versa. All right, so enough about operation servers. Now the control servers. That's the primary entry point for all management and administrative operations. Those expose REST interface, and also there is an administrative UI that I'll be showing you momentarily. So control servers, there is always one that is primary or active, and the others are in standby. If the active one fails, then the Zookeeper essentially elects the next one and promotes that to be primary. So again, there is no single point of failure in this architecture. Okay, a couple of words. Okay, this slide is actually requires constant updating. So this is some of the pre-integrated systems in the ecosystem. So you see at the bottom there are some of the endpoints, operating systems, and platform that are supported out of the box. Right now, the platform has SDKs written in Java, C++, and C. So that gives you a pretty good coverage in terms of integrating any endpoint device. You can see that even in this list, some of the endpoint architecture, some of the endpoint platforms have the operating system, the others do not. So we can take, for example, the C SDK and bake that directly into the firmware. The next step is the transport. The transport can be anything. We saw people implementing their proprietary transports for one reason or another. And the platform, Kaa as a platform, even allows you to run several transports simultaneously. Because, for example, for configuration, you may require reliable connectivity, whereas for notifications, you don't care that much. And if one notification just doesn't get delivered, nobody really cares. Kaa can be run on pretty much everything. So right now we provide distributions in Debian and RPM format. So that's pretty much any Linux that you want. We are pre-integrated with AWS, so you can deploy to Amazon directly from Kaa website. You can also download a sandbox image that you would run in your VirtualBox. That's how we typically do development, so that every developer essentially has his own sandbox on his own machine that he can use for any purpose. So there are some data ingestion, some data processing engines on the left, and the database support for the systems that are internal to the platform on the right as well. Okay, a couple things about performance. So you can read the exact numbers on the left. These tests were conveyed on the Amazon. So it's AWS mid-size nodes. What is most important here is not the actual numbers, but the fact that the graphs go pretty much linearly. So that means that by adding new nodes, you essentially linearly scale up the performance of the entire cluster. So Kaa is a completely horizontal platform that can be used for very many things. And I think I should show you a few of these. So let's switch gears. This is the demo that we did at IoT World. Was it last week or 2 weeks ago? Okay, hopefully it will work. Maybe not. All right, so that was a stand that is 6 by 3 feet large. And we have lots of things here going on. So this is a part of a smart city. There are 17 applications in here. They serve about a dozen various scenarios. So let me give you a quick idea. So this is a connected car. We have a STM32 Leaf Maple Mini, which is an OS-less chip sitting in this car, and then there is an RFID reader underneath. In the table, we glued in RFID markers that the car essentially reads by passing over them. And by doing so, the car knows its exact location on the table, and it can send its location to the other applications in here. So one application is the smart city, how do you call it, traffic control, which also happens to control street lights. So as the car enters a new segment of the road, you can see the street lights turning on. And the street lights are controlled by a completely different chip that is Ikonos EC19D, also OS-less, so the SDK is baked directly into the firmware. Now, as the car approaches home, we have geofencing implemented here, so the air conditioner switches from idle to active mode, and it starts preparing home for your arrival. cooling down the house. And as the car parks next to the house, it turns the lights turn on automatically. Now there is a small garden here, and this is an application written in for Android. It has the Kaa SDK embedded into it. So this application gives you control of the home appliances as well, and you can even irrigate your garden through this application. Now, as the car leaves and hits the road again, there is another scenario with the traffic lights. Essentially, as the car approaches the intersection, the smart city knows. Let's imagine that this is an emergency vehicle. So the smart city knows that there is an emergency vehicle approaching, so it switches the lights to green so that it would pass freely through the intersection without causing any trouble. Again, you see C19D here. Then this is one of my favorites. This is a smart advertisement, so you can see it here as well. What it does is there are two applications. One is sitting in the cloud. It has Kaa SDK embedded into it. That application listens to the Twitter feed and filters that by the configurable hashtags or mentions. And whenever it sees one of those hashtags, it distributes the message to the endpoint devices, which are LED boards. That allows us to overcome the Twitter limitation of 450 API requests per 15 minutes for a single API key. The last but not the least is the solar power plant. I also have it here right now. So what happens here is there are solar panels, and the Intel Edison board essentially gets the power voltages from the power plant and sends them over to our cloud in Virginia. And you can see that data being pre-processed in the cloud and pushed back as configuration to the tablet. So if you, for example, close one of the panels, you'll see how immediately the dashboard changes, reflecting the change in power output. All right. Now, the next thing that I want to do, okay, that's how I should have held it from the very beginning. The next thing that I want to do is switch gears again and show you how simple it is to develop applications with Kaa. So I want to try to develop an application right now, right here. So as usual with demonstration, something may fail, and hopefully it will not, but let's give it a try. So let me start by going to kaaproject.org. This is the project website, and if you go to get Kaa here, you'll see various ways in which you can get a Kaa instance. So there is an image that you can download and run in your virtual machine. You can get Debian or RPM packages for larger scale installations. You can browse the source code, but basically better way to do this is probably through GitHub. What we will do here is deploy a sandbox to AWS. Well, I will pretend that I deployed because I already have one up and running there. So you choose the region, and when you click on deploy sandbox to AWS, that leads you to Amazon, where you can spin off your cluster. Now, it is entirely free to test this out, especially with the Amazon offering of 750 hours, I think monthly, of the micro instance. So you can deploy Kaa server or Kaa sandbox into a micro instance, and you'll get your personal cloud to play with for free. So once you have this in your EC2 management console, so I have a few things here. Okay, let me relog in again. Once you have deployed, I will be using this instance. You have this public DNS. So you just copy it, paste it in here, go to port 8080/sandbox. Okay, I'll ignore this for now. So this sandbox is actually the environment which is full of applications for you to play with. These are sample applications that you can download the source code, or in some cases even the binary code, and start playing with that and hacking right away. So you can see that you can filter by platforms, for example, or by the platform features that you want to explore. Now, if you click here to Administrative Console, that leads you, let me just check that I chose the right one. Okay. That leads you to the administrative interface. So I'm logging in. Okay, things happen. So again, the same applications that you saw in there are available in here. So let's do this. We'll create a new application. And in order to do this, I have to log in as an administrator. And create a new application. I call it Dreamboard or Dream Raspberry or whatever else. The reason is because this board here is produced by a company who for some reason calls it Dream-Chiki. I don't know why it's so, but let's go get this going. So the application Dreamboard. Now I log off and I log in again as a development user. Okay, I had a Dream notifier here, so here is a Dreamboard. This is my new application. So what the development with Kaa typically starts from is from creating so-called data schemas. Remember, I promised you that Kaa runs on data structure definitions. So what we will do here is we'll create a new data schema for notifications. The default data schema is pretty much empty, doesn't have anything. So I'll create a new one. And I'll define the data structure that I will be using to notify my endpoints in this specific application. So let's call it a notification. Then the name again will be in it. Okay, let me pop this out for you. So can you actually see this on the screen? I know. It's in Europe, unlike me. Okay, can I put it here? No, I can't. Anyway. So what is important here is that what I have to do here is define the content of the notifications that will be delivered from the server to my endpoints. And I can do this entirely in the UI mode. So let's say that I want to put a message on this LED board. I have it connected to a Raspberry Pi here. So what I'm gonna need is a message. I can change the display name here and the prompt. Let's make this mandatory, and the field type is string. We'll leave this stuff empty. Okay, here we go. So we have a message in the notification, and let's also put in the number of times to repeat while displaying on the board. So I'll call this field repeat. Display name is repeat. Let's make it also mandatory. And let's make it integer. And the default value is 1. So this means display the message just once. All right. OK, so now we have this notification schema defined with the message as a string and the repeat as an integer. And I can close this. And pretty much I can provision this. So one more thing that I want to draw your attention to here is upload from a file functionality at the bottom. So this, if you're running a larger team, what you can do is basically have them commit their data schemas to a common repository, and so that everyone would just upload the schema to their server instance without having to do all this point and clicking all the time. All right. So we are ready to go here. So what happened right now is I created a new schema version for notifications. And the system configured that into my server. So what I'll do next is go to notification topics. So I have to create at least one topic to publish notifications to. And let's call this a mandatory topic. I'll make it mandatory so that every endpoint, even without subscribing to the topic, will receive notifications within the topic. And here we go. So I created a topic. The last thing here is in the endpoint groups. So you remember how every endpoint, when creating its profile in the system, can be segregated into the endpoint groups. So I will make that topic available to the default built-in group all, which contains every application that is registered, every endpoint that is registered within this application. So if I scroll down here and add a notification topic, I only have one, and I add it. OK. So now we are ready. So the server is set up. The next thing that we have to do is generate an SDK that will be used in order to develop our application for the endpoint. So I'll get it generated. You see here that you can choose any schema version for every aspect of the platform functionality that exists in the platform as of now. So for notifications, we have version 1 and version 2. Of course, version 1 is not interesting, so I'll create an SDK with schema version 2. The target platform will be C. We don't have event classes. We don't have any user verifiers. So that's it. Now when I hit generate SDK here, it actually got me this SDK that now I will copy into my project. OK, that's my Raspberry Pi. I'll remove everything I had here. This is something that I tested with. So I have a project, and I'll show you in a moment what this project consists of. It's very small and simple, but you have to excuse me. I won't do more of the typing here because it's really time-consuming. So I'm putting this client SDK that I just obtained from my instance of application in my Kaa server instance into my project. And the next thing that I want to do here is put that onto the SD card for my Raspberry Pi and get the Pi booting up. OK, that's my alt. Dream notifier. Let's delete this. All right. So on the left here is the SD card of the Raspberry Pi that I will boot from in a moment. On the right is my project that I'll show you in a second. So let me plug this off. Okay, I still need these. OK, can now be safely removed. Now you have to excuse me for a moment. Okay, so I have Raspberry Pi here. I have a battery pack. And when I stick this in, it starts booting up. So let's give it a couple of minutes to boot up. While it does so, let us explore what exactly is in this project. So I have it in here. So libs now doesn't have anything. Let me refresh, because I just threw in a new package. So it's only tar gzip that I put in a moment ago. And src only contains the Dream Notifier C. So let me first go in and unzip. So this is Kaa hex, Dream Notifier. Okay, you know what? I'll just build it here. Build. And that will automatically unzip stuff for me. Okay. Seems to be good. So now the SDK package got automatically unzipped in there. I just didn't want to go there and do that manually. My build script actually does that for me. So you can see that under libs Kaa, I now have the SDK untarred and unzipped. That's the SDK that my server just generated for me. Now we can go back to here to Dream Notifier. What I have here is really, really small and simple. So I have a main function in here that just creates an instance of the Kaa client, which creates a context of the Kaa library for me. The next thing is it creates a notification listener. So whenever a notification comes in, what was that? Oops. That was my SD card. That's not what I expected. I've never seen a Raspberry shooting SD cards before. That's not the demo. All right, so what happens here next is I create a notification listener that essentially subscribes my other function in here called onNotification to the incoming notifications from the server. And what happens next is I start the main client loop so that it initiates a connection to the server and starts listening to whatever comes from the server. When everything concludes, it destroys the client. So now a more interesting part here is this onNotification function, which creates a buffer in here, puts a notification message data into this buffer, and feeds that into a third-party library that I just use here for displaying information on this board. Yeah, you have a question?
So where, I'm just missing from here, I don't know if you're going to touch on this later on, but where do you specify where your server is? Or is this where your company comes in? Is everything going through your servers first?
No, no. Actually, I had that server, right? The server that I was generating the SDK from, it knew its own location, so it automatically baked the server location into the SDK for me. So when I was generating the SDK, the server automatically put its own location into the SDK.
And what if, again, maybe this is in the documentation, but what if I'm behind a VPN and that kind of scenario?
In the very beginning, remember when I opened the sandbox screen, it showed a pop-up saying, let's change the public host IP address. You can do that either through the sandbox UI, so basically that configures for the server the way in which the it changes the location of the server for the endpoints. So if you change that to your external IP address or host name, that information will be baked into the SDK.
And then the last question, just kind of, because anyhow, so the question is, you create a new schema for the notification. If we were to have to create our own kind of transport protocol, how much effort would it be to actually then map the new protocol to the actual schema?
It's not a large effort. We've been doing that on several occasions. Essentially, the way we implemented this is to abstract out the implementation of the protocol as much as possible, both on the endpoint of the transport protocol. Both on the endpoint and on the server side. So there are easily replaceable modules in there that are completely independent from anything else that you just take. You can take a look in the open source community how they are implemented. You implement your own, you stick that in, and it just works. So the way in which the protocols are built in the platform is like 3-layered. There is the transport layer, there is the protocol, there is a platform layer, and there is application layer. So application layer is something that the platform creates based on your schemas for you. The platform layer is something that ships with the platform itself. This is where our pings, things, syncs, our basically platform level messages are implemented. And then this transport layer is again something really abstract that you can replace, abstracted that you can replace with whatever you like. Okay, I'm actually trying here to figure out where my Raspberry is because it registered on my phone as a relay, but I don't know its IP address. So while it does so, let's get back to this. So I fill in the buffer with the message data in here, and I feed that into an external library. There it's just a library that you can go and download from the network that works with that specific LED board, and it will display that message for me. Also, I use this repeat parameter that you remember me configuring into the schema. I use that to cycle several times through the message output. Now, what is cool here is if you go to the notification type here, you'll see that it has your data semantics, your data structure, precompiled here into the C structure. So if I were to throw in more parameters in there, they would all appear in this structure as well, including the arrays, unions, or whatever else you might fancy to put in there. All right. I think it still needs a minute or so to find the Raspberry on the network. Does anyone have any questions so far while we are waiting? Yeah, go ahead.
Quick question. If I change my mind, I need to change my schema or whatever, do you have to regenerate the SDK?
Can you speak out a little louder?
Sorry. If I made a mistake, I want to make some changes to the schema or the message. And
I got it.
Do you have to go and recreate the SDK? Is that how?
Oh, absolutely. What you do is you go back to the administrative UI. You go to notifications, for example, and you just create a new schema that you can have either, well, let me show you. I actually have this schema in here in JSON. So you have your schema checked into your repository, right? So if you want to make changes, you just upload your existing schema in there, and it pops up with all the fields that you already had, and you can do your modifications, like delete, add, do whatever you prefer. Okay, so if I save this schema, that will show in my specific instance of the server as a new version of the schema. So in production, you will probably want to avoid creating schemas that you won't use in reality because they will stay in the server forever, and that is done for purpose so that the server essentially remains backwards compatible with all of the historical schema versions that you ever put in. But in your development instance, you can play with this for as many times as you like. Okay. Let me see which one of this is Raspberry. No, that's not it. Okay, this looks like a Raspberry. I'm lucky here. So if you remember, I put my project a few minutes ago onto the SDK, again under Dream Notifier. And I think we are ready to build. So this application now has the SDK that I generated from this new application from the instance that I was running. So what I will do is build deploy, for example. This is a very simple build script. You can it just basically launches CMake and make first for the SDK and then for the application, and creates the binary assembly. So there is no secret sauce in there. So let's give it a moment to compile. And it actually will not only compile, but I think it will also run the application.
So if I can ask again, in terms of authentication security, is that also baked in to the lib that you deployed?
So in this case, what I did is I used one of the existing protocols and the authentication schema that is essentially available from open source. What you can do is you can go into the SDK and you can replace the protocol, for example. So if I go here, this libs, src, Kaa, you can see, for example, Kaa protocols in here. So the protocol that I'm using is called Kaa TCP. This is very lean, very small header protocol that is implemented in here. But you're free to replace that with something else. There is a Kaa platform protocol is not what you're looking for. There is platform. Yeah, there are basically, this gives you all the headers that are kind of external, that are replaceable, that can be either specific to the specific platform that you're using, or they can be specific to your project. So by implementing these interfaces, you can replace any aspect of the client operation, essentially. All right, let's check if build has completed. So this console is actually on the Raspberry. Okay, I have the binary here, so the only thing that I'm lacking is that other binary that drives the board, the LED board. And I have it built for 32 and 464 architectures. Okay. All right, we're ready to run. Dream Notifier, and I think I have to sudo this because it won't otherwise have access to the USB. All right, well, at least it didn't crash. That's good. Now, let's go to the notification topics. Okay, I'll leave this part. So I have this notification topic here, and I can send a notification directly into the topic. As you can see from knowing the data semantics, the UI automatically generated a form for me. So let's test this out. Hello, world. Hello, world. So it actually worked. All right, well, that's pretty much it. That's all I had for today, and I think we are ready for Q&A.
Okay. First of all, great job, Andrew. Thank you very much. Q&A. Anybody have any further questions?
Are there any case studies that you have in terms of in markets where you've installed and configured Kaa at scale?
Yeah, there are use cases actually in various markets. Where we started from is in the consumer electronics space, and especially wearables. So there are use cases in which the platform is used to essentially collect telemetry data from the wearables or from just generically consumer electronics devices, and also there are use cases in which we are changing the behavior of the endpoint devices by changing configuration, for example, so that we offload some of the data processing from the core network from the core to the edge of the network. Then there are plenty of use cases right now in the community outside of CyberVision where people are using this platform to do things like, well, vehicle telemetry, for example, for vehicle telemetry, car telemetry. For example, for usage-based insurance. There are companies who use it not only for IoT, but generically for building just applications. So there is one startup that I really appreciate all the work that they put into this. They actually helped us with some of the testing and some of the implementation. What they did is they have built an application that integrates into pretty much every data source about you personally, like your Facebook, your Twitter, your Swarm, your whatever else, and it presents you with a dashboard of your life, essentially how you spend your time, how you spend every day of yours. You can set goals in that application and so on. So they were originally looking at a something like a 6 months initial time for creating a beta, and they ended up with a beta application built in just 2 months by using the platform.
What size installation in terms of how many nodes in the field for a given installation?
The largest installation is in the probably ballpark of hundreds of thousands of nodes, but we actually stress tested the system to, well, I had it in the presentation here. Yeah, so we stress tested the system to 1.5 million messages on 16 nodes, for example, and of course, depending on the application, that will give you, well, depending on how your application uses the messaging, that will give different results in terms of the amount of endpoints that it will support, but it's actually pretty good.
So you presented a lot on the device side of how easy it is to deploy this and whatnot. How easy is it to extend now the server side?
Pretty much the same concept applies. So first of all, the platform is 100% open source. So you are free to go in and hack whichever aspect of the functionality you like. But even without doing so, pretty much everything is accessible through REST. So you can hook up any application based on REST. In terms of data extraction, for example, you remember I gave some examples of the databases and data processing systems that you can use to process the data that is collected from the devices. If you're not satisfied with those, then, well, actually, over this weekend, one of my colleagues, he created a new, we call these log appenders. He created a new log appender for pushing data from endpoint devices to a new system. Doesn't matter which exactly, but it only took him 1 weekend.
Thanks for the great presentation. I have a general question. How would you differentiate your platform compared to the others? There are quite a few others, it seems, out there. So if you would take a minute. Thank you.
Well, the first and obvious differentiator is the fact that this platform is 100% open source. That filters out, well, I would say 95% of the competitors on this market. Many of the competitors are actually platform as a service. So they give you essentially access to their cloud, and they charge you for using this cloud for every message that your endpoints send to each other. This platform is very much unlike it. So first of all, you remember I said that the first thing to remember about Kaa is that it's not a messaging bus, right? So this platform is essentially created for the IoT vendors to serve as a basis for building their products and their applications. So unlike with the message bus, which you can hook up at any time, right, to just enable messaging from point A to point Z, this is something that speeds up your time to market. So by using this platform, like I said, like in this use case was that startup who was originally looking at 6 months release schedule. They actually landed with 2 by just finding this platform and using it.
How do you enable connection between multiple devices? I mean, you have events and notification. How can you enable, say, the one device generate an event and another device can subscribe to it and do something, you know?
Yeah, well, the way it works is, first of all, again, everything is governed by these data schemas, right? So what you do is, there are 2 levels in there. There is something that we call event classes. So an event is an instance of event class. And event class is something that is defined by a schema. So for example, if you want to change volume on your laptop, for example, remotely, right? Your laptop can expose So there are event classes and there are event class families. So event class families are groupings of the event classes. Now, an event class family can be sort of a protocol for you to do certain operations. So for example, a change of volume operation, right? It can be exposed by a laptop, by a TV, by a music player, by something else, right? It's the same class family that shares the same definition of the schemas, like the volume level and the acknowledgement from the recipient, right? You can use the same definition of the class family across multiple applications, across multiple products, to basically build a seamless integration from your controller application, which might be on the phone. So the way in which it works is typically within the class family, there is a request to do something, and then there is a response. Both are defined by separate schemas, and that's how you create your protocols, which make it possible for you to bridge these endpoints.
You need a control application. You cannot just run events and other devices subscribe to the events, such as in the Amazon, they have this Lambda where you can just run a piece of code without having a controlling application.
Okay. I didn't realize that this was what you were asking. You can do that as well. Absolutely. You don't necessarily have to have a physical controller. What you define is just these schemas which define the protocol that the endpoints use to exchange data, and these events can be used either within the application. So for example, several of your thermostats at the house can communicate in the same network by telling each other, okay, now it's time to I don't know, cool down or heat up or something like this. Or you can do that across the applications. So in that case, you can have a controller, which is your smartphone application, for example, and it would communicate to the other applications like this. If you remember from the video, I had this irrigation thing. That was an example of a controller application.
Andrew, thank you very much.
Thank you, Mitch.
Thank you to Kaa. We have just a few more slides, probably 3 minutes. Let me just... Okay, so it's time for member announcements. So if anybody's looking to hire somebody, if you're looking for a job, if you have any special offers for nyc-iot, maybe you're giving away something. Anybody have anything to say? Okay. And state your name and...
Hi, everyone. My name's Farouk, and I teach computer technology courses in New York City College of Technology. We're part of City University of New York. And I'm looking for project ideas for our student projects. Our students are working with this technology, especially all the hardware that you saw in the smart city demo. We are very comfortable, putting the hardware together and basic software applications. So if anybody has any ideas, they would like to get some work done by the students, basic research or development work, please, you can get in touch with me through the Meetup group. And the other thing I'm looking for is I'm also the internship coordinator for our computer technology program. So if anybody's looking to hire any interns, we have students who are very good at this technology, and again, you can get in touch with me. I saw a couple of companies in that slide that mentioned a lot of different companies, involved in IoT, and I think Keezy is one of them. And one of my students this semester was working for Keezy as an intern, putting together those locks, So you can get in touch with me through the Meetup group. My information is there. Thank you.
Okay, great. So your name is Farouk at City College of New York, and he is looking for projects for his students and also for placements for interns. Okay, great. One more. Let's see.
My name is Taumai. I work at Philips Research North America. We're located about an hour north in Briarcliff Manor, although we will be relocating to Cambridge now to be near MIT. We're a bunch of PhDs who are looking for like-minded people. We have a couple of openings for cyber physical space, for EE majors, I'll surely talk to you, Farouk, but if you just go into our website, it's focused on the research part. So smart city is kind of in our vein.
How do they contact you? How do people get
I'm on the Meetup. My name is Taumai, T-A-L-M-A-I. I'll be here afterwards. I think it's just easier to afterwards look for me. Yeah.
Okay. Great, sure. Talmai from Philips Research, and he's talking about they're moving from Briarcliff Manor to Cambridge, and they have openings, potential openings for PhDs and other people who are skilled in IoT and related fields. Okay, Melina.
Hi, my name is Melina Sidler. I'm a Senior Vice President of Sales for CyberVision. Obviously, Andrew wouldn't make this announcement, but I will. So CyberVision traditionally is a 25-year-old IT services company. We have several locations: New Jersey, Miami. Development and R&D is done in Eastern Europe. If you guys need a project done and smart people, such as our CTO, please contact me. We're basically an outsourcing company specializing in big data, mobility, wearable technologies. We're working with several large companies in Silicon Valley. As you could see there, a lot of partnerships. So again, my name is Melina Sidler. Please don't hesitate to contact us for all your IT needs.
Okay, thanks, Melina. And also one other thing to mention is that if you want to be on the mailing list for CyberVision, specifically for Kaa, they have some other things coming up. Please initial by your name in the sign-in list and just put a check mark there so we'll know that you would like to sign up for the list. They're having a webinar coming up on Kaa open source IoT platform. Anybody else have any question? Any?
I'm Jolly from the Internet Society. I'm your videographer tonight. He referred to the Internet of Things Fair. This is something that I wake up in the middle of the night and think about because I haven't finished editing it, but I will. And it's a really good event and look forward to the fact that I will. It's one of my projects right now to get this finished off. I will post it. It's a really good piece of video. Generally, I do webcast live, the Internet Society. If you go livestream.com/Internet Society, you'll find our stuff. Just week before last, I covered a thing at the Columbia at the School of International Public Affairs or something, where they did this big conference, and they included one session about Internet of Things and security that was very good. I posted about it at the time. I'm going to post about it again. Another thing that we covered just this last week was a conference in DC about, we have an interplanetary chapter that is dealing with delay-tolerant networking, and this is, I don't know if you'll find applications for this, but it's very interesting, this whole business of how you communicate with things when you can't get at them right away, when you've got to wait for things to get from one point to the other. So there may be applications on that. So that was a very good thing. So those are the two things I'll recommend. Thank you.
Great. Thanks, Jolly. And we thank Jolly McPhee for tirelessly videoing all of our sessions. So thanks again to Jolly. Okay. Anyone else have an announcement? Okay.
So my name's Tom Payne. I come from a company called Applause. We provide testing services. We sell testing services. But we do that with mostly for mobile devices, websites, but more and more we're doing it for clients with Internet of Things devices. We do it with like Fitbits and different kinds of devices. On the flip side, what we do is we leverage a community of about 200,000 testers around the world to do this testing. So it's kind of testing out in the wild. If you do a Fitbit in the gym or smart TVs or what have you. You can join that community, and we actually pay you for doing the testing. So if you want to go to utest.com, you can join the community and get experience testing Internet of Things devices, bolster up your resume, and get paid at the same time. So. So Applause is the company, is the company that sells the services, and UTest is the community that provides the body to do the testing. That's why you, the letter U and then T. The company used to be called UTest. Is now the rebranded Applause. Got it.
Great, thanks. Any other? So I'll put on my other hat. I work at Wadio. We are a data service exchange for connected device platforms. And we are looking for interns, so we'll talk afterwards. We're looking for interns, both technical, who are writing software for the Internet of Things, as well as some marketing people. So please come see me afterwards if you're interested in that, or if you know of people that are interested in that. Any other announcements? Okay. So we'll move on. Just two more slides. One is that we have a corporate council. So the IoT Central Group has been growing over time. We've reached over 2,300 members in less than a year since our first event. So it shows that IoT is really a hot field right here in New York City. We're putting together a corporate council really for people that are in Fortune 500 companies. And we'd like to discuss how IoT could benefit those companies in a smaller forum. So it's really geared towards a smaller discussion group of people who are in a Fortune 500 company. So if you're interested in that, come see me or contact me at mitchell@iotcentral.co. And have to end a meeting with a call to action. So if anybody's interested in organizing events, we have plenty of opportunities within IoT Central right here in New York City. You can get involved in many ways. You can be an event chair in which you may come up with the idea, or we can even give you an idea and you help to organize that event. If you have an IoT-related startup and you'd like to present in a future event, let me know. We can see how that fits in the schedule. If you would like to participate in a demo event, such as the IoT Fair, let me know. That's geared towards companies that have nice demonstrations, things that really show use cases of IoT, either verticals, let's say a vertical use case, or even horizontal technologies that you want to demonstrate. We're also looking for IoT subject matter experts. So if you are an expert or you know an expert that would like to speak at a venue like this, we're open to that, whether it be on the IoT technology side or even on the IoT business side. And if you have any suggestions, you can let Michael Wang, Bart Chappie, or Naveen Mishra, who's right here, know. He's actually right here. Know if you have any ideas. I'd like to take this opportunity to, again, thank General Assembly for hosting. I'd like to thank Atmel for sponsoring. I'd certainly like to thank Kaa for CyberVision, who presented Kaa Open Source IoT Platform today. Thank you very much for coming. And I'd like to thank a few organizers. That would be Michael Wang, who specifically helped with this event, and Naveen Mishra, who specifically helped with this event. So thanks, everybody, for coming. This is the contact information. If you'd like to get in touch with us, Twitter, you might have seen some of the tweets show up on the display here. You can find us at Meetup. You can find us on YouTube. It's youtube.com/nyc-iot. And if all that doesn't work, you can send an email. So thanks again to everybody for coming. And if you have any questions, feel free to contact me.